Howdy students, this is going to be the second video for this part of notes, and today we're going to look at electronegativities that help us determine what bond type or bond polarity is in a molecule. So let's define electronegativity. We had learned this back in Unit 4, periodic trends. Electronegativity is a measure of the attraction of an atom for a shared pair of electrons in a bond. So if we remember correctly, electronegativity values increase across a period and up a group. So using colors as a visual, we can see that generally speaking, there are some exceptions. When we move across a period and up a group, we increase in electronegativity value. We increase in the amount of attraction that an atom has. So the most electronegative element is fluorine. And there's one thing to note: the noble gases do not participate. And the reason for that is that they have a filled outer valence shell, and so they don't need to. So we're going to use electronegativity to help us determine bond polarity. And so in our notes, there is a scale that we're going to go ahead and fill in. So when we take two elements, we're going to be comparing the two, and we're going to be taking a difference, a subtraction. And we're going to see an example here in just a moment. But if we have a difference of greater than 2 in the two elements, then we're going to have a complete separation. And in this case, what we form are ions. And because of that, we have an ionic bond. Now, if the difference isn't that great, it's between 0.5 and 1.9, we have a polar covalent. So on this one, no separation, but it's an unequal sharing of electrons. And this is where we get our dipole that we were talking about earlier. So if I was drawing a dipole, it would go this way. And the partial positive is here, and the partial negative is here. So it wants to form ions, but it's not quite there. And then the last part, we have a difference in electronegativity of less than or equal to 0.4, then we have a non-polar covalent bond. And no separation, and it is an equal sharing of electrons. We're going to do some examples, and that will be the end of this video. So the first one is HBr. And I'm going to go ahead and exit here and show you. We have given out this sheet that has all of the values for the periodic, the electronegativities on the periodic table. So our first compound is H with Br. So I'm going to find those two on my table, and what I'm going to be doing is a subtraction. So I'm going to head back to the PowerPoint. This is the table that we're using to get these values. So on the table, you're going to get a value for bromine around 2.96, and for hydrogen, you're going to get about 2.20. And what we're wanting to do is take the difference. So once again, this is a subtraction. And then because of that subtraction, we're going to be able to use this value to determine bond polarity. So because 0.76 falls in the range of 0.5 to 1.9, it is a polar covalent bond. There is an unequal sharing of electrons, and we have a dipole moment, a partially positive side and a partially negative side. Next example would be NaF. Fluorine is the most electronegative. We get 3.98. Sodium is 0.93. When we take the difference, we get 3.05. And that is greater than or equal to 2, which means it's an ionic bond. So we have complete separation, and we have formed two ions, Na plus and F minus. And this is when we would show the transfer of electrons. from one to another. And the last one, N2, you might be thinking, well, that's the same element. It has the same value in electronegativity, so the difference is 0. Therefore, nonpolar covalent compound. And that'll be it for this video.